Nuclear fission is a splitting of an atom into two parts. It can release an enormous amount of energy, and that can be used in war. This is the bombing of Nagasaki, which helped bring World War II to a close, but was associated with an enormous loss of life. It can also be used in peacetime. These are two CANDU reactors built by Canada and operating in China. Integral fission is the splitting apart of an integer into two parts. So here we have the number 30. We're going to split it into two parts. In integral fission, the larger of the two parts is always on the right. So 15 is larger than 2, so it's going to be on the right. We could also split it 3 times 10, or 5 times 6. Every time, the largest piece is on the right. Which of these three is correct integral fission? In integral fission, we want to have the balance between the pieces as even as possible. So 2 times 15 doesn't work because the 15 is much too heavy. 3 times 10 is a little bit better, but 10 is still too heavy. 6 times 5 works. 6 and 5 are as close to each other as possible. We can also split 6 into 2. Here we go. Remember, the bigger piece always goes to the right. So you notice that 3 is going off to the right. That is the solution for the integral fission of 30. What about 45? Well, you notice it has the same pattern. That's the pattern there. So both 30 and 45 have got this same pattern. What I want you to do now is to look for 3 consecutive integers under 50 that have the same pattern. I'll give you a hint. It's not this pattern. 33, 34, and 35 all have the same shape. So that's the solution, 33, 34, 35. Okay, next question. Is this the way to split 1000? No, this is not the way to split 1000 because 20 and 50 are not as balanced as they could be. This is the correct solution, 25 times 40. Next problem. I want to know all of the integers less than or equal to 100 that have this shape. Turn off the video, solve that problem. The first thing that you might have noticed is that we need 4 prime factors. Are any 4 prime factors sufficient? Well, 2 times 2 times 2 times 2 works. 2 times 2 times 2 times 3 works. 2 times 2 times 3 works. But 2 times 2 times 2 times 5 does not work because you don't split 40 into 4 times 10. Instead, you would split it into 5 times 8. So this does not work. 54 does work. 56 does not work for the same reason. 60 does work. 81 works. 84 does not work. 88 does not work. 90 works. And 100 works. So that's the solution. We're now going to take a ride with the number 2. We're going to start with 2, and every time we're going to multiply by 2 to get the new integer. Concentrate not only on the numbers, but also the patterns. Now I'm going to take a big jump and another big jump. We could do that with any prime number, so we can take 3 and multiply by 3 and keep on going. We can also do it for 5, and we could keep on going if we wanted to. Back to work. I want you to find an integer, the smallest integer, which fills this shape. It's 40. Now I want you to find the smallest integer which fills this shape, or this shape, or this shape. You choose which shape you want to solve and solve it. The smallest integer to fit in this shape is 460. In this shape, 88. And in this shape, 220. The next problem is really tough. In it, you're going to get 5 shapes. This is the first one, shape A. And you have to find the smallest integer that will fill one of these shapes. It doesn't have to fill them all, it just has to fill one of these shapes. What's the smallest integer that will fill one of these shapes? So I'm going to keep the right-hand side the same for all of the shapes, and I'm just going to change the left-hand side. So this is shape A, this is shape B, shape C, shape D, and shape E. So what's the smallest integer that will fill one of those shapes? Again, shape A, shape B, shape C, shape D, and shape E. The smallest integer that will fill shape A is 920. The smallest that will fill shape B is 880, and this is the best of the lot. The smallest that will fill shape C is 1200. The smallest that will fill shape D I thought was 800, but that's not the best way to split up 800, so that's not correct. The correct answer for D is 2464, and for E, 3024. You can see that we could organize shapes based on the smallest integer that fills them. So we could organize them, and B comes before A, comes before shape C, comes before shape D, comes before shape E. Let's do that starting at the lowest integers and moving up. So the first time that we encounter this shape is 2, then we encounter 4, then we encounter 8, this shape, then we encounter this shape at 16. The first time we encounter this shape is at 20. The first time we encounter this shape is at 32. The first time this shape, 40, 64, 72, 88, 128. I don't promise this list is complete, but it's fun to see when a shape first appears on the list, and it's not an easy task. You should look at creating your own problems and getting your kids to create your own problems with this beautiful diagram. Of course, this is really just the standard factor tree, but with extra conditions attached. And again, the extra conditions are that any split that occurs has to be as even as possible. And secondly, that the right is bigger or equal to the left in that split. If you don't have a colored photocopier, there's a black and white. If your curriculum demands, integral fission will also allow you to talk about symmetry. 32 is the smallest number with no symmetry. Let's look at a number with a lot of symmetry, 256. We can take 256 and we can rotate it. And you notice that the shape stays the same as we're rotating. We can also look at mirror symmetry. Here's a vertical axis. Here's a horizontal axis. So it's got mirror symmetry and it's got rotational symmetry. We can look at different numbers and we can say whether they're symmetric or not symmetric. So 135 is symmetric. It has both mirror symmetry and rotational symmetry. 144 has got rotational symmetry, but it doesn't have mirror symmetry. Enjoy asking your own questions using integral fission as the backdrop. It's a rich way to explain numbers and to give a nice vibrant image of numbers in a way that kids can grapple with and play with. Enjoy.
In many arithmetic problems, you'll have a long string of numbers separated by different combinations of operators. You might have to multiply, divide, and add in addition to dealing with parentheses and exponents all in the same problem. Here are some examples.
Don't worry, a standard order of operations has been developed just for these types of problems.
You always work from left to right with these strings of numbers. The standard order of operations is to do parentheses first, then exponents, multiplication and division are next, and addition and subtraction are last.
Lots of people use a mnemonic device to remember this order of operations. The first letter of each word in the order of operation spells PEMDAS.
Sinking in, isn't it?
Here's an example of a math problem that you must figure out using the order of operations to get the right answer.
5 squared plus 9 minus 3 times 4 minus 8 divided by 2. Now let's solve this puppy. Moving from left to right, we have to do any operations in parentheses first. 9 minus 3 is in parentheses, and it has a value of 6. So we substitute the 6 for the 9 minus 3. So the problem now looks like this.
Since there are no more parentheses left, we move on to the next step in the order of operations, exponents.
Again, moving from left to right, we find 5 to the second power.
Remember, the exponent is just the number of times you multiply the base number by.
So we multiply 5 times 5 to get 25. We put 25 where 5 to the second power is. So our problem now reads 25 plus 6 times 4 minus 8 divided by 2.
There are no more exponents. Multiplication and division are the next step in the order of operations.
Starting on the left, the first multiplication problem we find is 6 times 4, or 24. 24 replaces 6 times 4. We continue moving to the right and find a division problem, 8 divided by 2. The answer to this is 4, and 4 replaces 8 divided by 2. So the problem now reads 25 plus 24 minus 4.
Addition and subtraction operations are all that's left. Beginning on the left, we add 24 and 25 to equal 49. 49 replaces the addition operation, so all that remains is 49 minus 4, or 45. So, the answer to 5 to the second power plus 9 minus 3 times 4 minus 8 divided by 2 is 45. Okay? Everyone take a breather.